So in this question, what I want to do is demonstrate how to solve any circle theorem question, not just this one particular example. I'm just going to use this example to highlight those key techniques. So part A, this is the question by the way, highlighted in grey. Part A says find angle DCB, so you've got to be able to read this three-letter notation by the way for circle theorem questions. So DCB means the angle at C, always using the angle in the middle of the three letters. So I want to work out that angle. Now, the first kind of mini technique, I say mini technique, but it's very important, is that when you're doing a circle theorem question, work out any angle you can with any circle theorem you can see. Now, part A is not really trying to demonstrate the harder stuff. It's actually quite easy. It's just saying, right, apply a circle theorem. So here is a quadrilateral, and it's a cyclic quadrilateral because all its corners are touching the circumference. So why not use a circle theorem that relates to cyclic quadrilaterals, which is opposite corners in cyclic quadrilaterals add to 180. So basically angle C is 180 minus 50 because they have to add to 180. So that makes angle C or angle DCB 130 degrees, just like it says over there. Now part B is getting a little bit harder. It says find angle BDA. BDA, well, there's no actual drawn in angle BDA, so I have to draw in my own line like I've done here, and now I can draw the angle BDA. The angle is at D, is this little bit there between the dotted line and the diameter. So that's the angle we want to work out, but like I said before, work out anything you can. So I've actually made a triangle now, so I can say basically that angle has to be 90 degrees because there's a rule that says angles in semicircles are right angled. Basically means that is 90 degrees because you've got a semicircle going on, or basically a triangle with a diameter as a a base as a diameter, wrong way around there, and the other corner, which is opposite to diameter, must be therefore 90 degrees. Now, we know that's 90. What can we work out next? Well, we've got a triangle. Those interior angles in triangles always add up to 180, so basically this last angle at D must be 180 minus 50 minus 90, or the other way around. Basically, this angle D or BDA, like we wanted, is equal to 40. So that demonstrates some of the key points. So the key points are know or understand how to use three-letter notation for angles, sometimes draw in your own lines, and very importantly, work out anything you can, any angle you can, because eventually it will lead you to the answer you want, because the answers don't come out straight away. Like in any math question, you have to work out one thing, then the next, and eventually you get to the answer.